students, now we will discuss about IoT levels. On completion, students will be able to understand the basics of IoT levels. What is IoT? A phenomenon which connects a variety of things, everything that has the ability to communicate. Internet connects all the people, so it is called the Internet of People. IoT connects all things, so it is called Internet of Things. From any time, any place, connectivity for anybody, anyone. We will now have connectivity for anything. Based upon the number of monitoring nodes used, the type of database used, complexity, simplicity of analysis, computation, there are 6 levels of IoT. Different applications are implemented based on this level. The IoT systems consist of these following components, that is device, resources, controller service, database, web service, analysis component and application. IoT levels. Device. The IoT device also allows identification, remote sensing, actuating and remote monitoring capabilities. Resources are the software components on the IoT device for accessing, processing and storing sensor information or controlling actuators connected to the device. Resources include the software components that enable network access for the device. For the programs that we have written for object detection using IR sensor to find out the distance using ultrasonic sensor, etc. IoT levels and deployment templates. Controller service. Controller service is a native service that runs on the device and interacts with the web services. The controller service sends data from the device to the web service and receives commands from the application for controlling the web services. For example, the ESP8266 programming, setting of API keys, SSID, etc. Database can be either local or in the cloud and stores the data generated by the IoT device. Web service. This acts as an interface between IoT device, application, database and analysis components. Web services can be implemented using HTTP and REST principles or using WebSocket protocol. IoT levels and deployment templates. Analysis component. The analysis component is responsible for analyzing the IoT data and generates results in form which are easy for the user to understand. Analysis can be performed either locally or in the clouds. Application. IoT applications provides an interface that the user can use the control and monitor various aspects for the IoT system. IoT level 1. It has single node device for sensing, monitoring, actuating, storing data, performing analysis and hosting application. Data involved is not big, so data is stored in local database. It is stored for modeling, design, low cost and low complexity solution. Primary analysis requirement is not computationally intensive, so can be analyzed locally. For example, home automation. Here just you can see the level. Device, resources, controller service is connected to the database. REST WebSocket services and application is connected. IoT level 2. It has single node service for sensing, monitoring, actuating, performing analysis and hosting application. Data involved is big, so data is stored in cloud. It uses cloud-based application to visualize data. Primary analysis requirement is not computationally intensive, so can be analyzed locally. For example, smart irrigation. Here you can see the IoT level 2 device, resource, control service is connected with the REST WebSocket services. The database is connected with the WebSocket services and with the application. IoT level 3. It has single node device for sensing, monitoring, actuating and hosting application. Data involved is big, so data is stored in cloud. It uses cloud-based application to visualize data. Primary analysis requirement is computationally intensive, so can be aggregated and analyzed in cloud. Example, tracking, package handling. Here you can see the IoT level 3 diagram. Here the device, resource, control service is connected with the WebSocket communication. It is connected with the database and the application. IoT level 4. It has multiple nodes or devices for sensing, monitoring, actuating, performing analysis and hosting application. Data involved is big, so data is stored in cloud. It uses cloud-based application to visualize data. The primary analysis requirement is computationally intensive, so can be aggregated and analyzed in cloud. It has two observer nodes, that is local and cloud-based. They can be subscribed to and receive information collected in cloud from IoT device. They can process and use that information for various applications. Here multiple devices are connected. IoT level 5. It has multiple nodes or devices for sensing, monitoring, actuating. One coordinator node for collecting and sensing the data to cloud by controlling service. Data involved is big, so data is stored in cloud. It uses cloud-based application to visualize data. Suitable for wireless sensor network. Primary analysis requirement is computationally intensive. Analytic component analysis the data and stores results in cloud and make prediction. For example, forest fire detection. Here is the level 5 diagram. Level 6. It has multiple independent nodes, devices for sensing, monitoring, actuating and sensing the data to cloud by controller service. Data involved is big, so data is stored in cloud. It uses cloud-based application to visualize data. Primary analysis requirement is computationally intensive. Analytic component analyzes the data and stores result in cloud. It has centralized controller which is aware of the status of all the end nodes and sends control command to the nodes. Example, weather monitoring and structural health monitoring. Thank you.